Hey everyone, Philip BD for Redstone here, and today I wanted to shortly introduce you to the Oracle extractable value and tell you a little bit more about Redstone and how it did we implement it. So for those of you that are not familiar with us, Redstone is the fastest growing Oracle on the market right now. A couple of facts about us. Last year we happened to raise 15 mil from VCs and angels in the space. We are one of the major Oracle players that is currently focusing a lot also on RWA narrative. Recently announced our deal with Securitize and BlackRock's Build Fund, where we basically deliver data for all future tokenized funds with Securitize. We also recently introduced Redstone Vault, which is the fastest on-chain Oracle that ever existed, which delivers data to mega-ETH with, I think, 2.4 milliseconds latency. And we're a quite small team. Most of us live in Warsaw, and we're generally like easygoing guys that have fun here. Okay, so first of all, I'm not sure like how technical the crowd is. Maybe the first question to you: who knows what an oracle is and what an oracle does? You can like raise your hands. Okay, so pretty much most of you. In short, an oracle delivers data for smart contract execution. Currently, it's mostly market data, and around 95% of the data we deliver is basically price feeds of assets, mainly crypto. I like to ask this question very often. So like, what is currently the most utilized price feed in crypto? Anyone has any idea? No, I mean, not the Oracle provider, but that's true as well. I mean, the actual asset. So let's say BTC USD or nope. ETH USD. That's like around 90% of the queries are for ETH USD. That's because one, most of the DeFi still happens on ETH, and all the L2s are also based on ETH. And two, there are a lot of ETH derivatives, so like ETH LSTs, ETH LRTs, that are also usually ETH denominated, right? So very often the ETH Oracle is still needed for those queries. Okay, so Redstone has currently 150 clients, supports 80 plus chains, secures, it's 9 billion, I think, or 9.5 now. So what are the oracles used for, right? Those are the lending markets, like Morpho or Venus, for example. Leverage protocols, Gearbox or Delta Prime, for example. Staking and restaking. Here we posted like, I think it's Lombard and Puffer. We did capitalize a lot on restaking because we introduced what we like to call contract exchange fees, so fundamental price fees, which basically, instead of just aggregating the liquidity sources for the asset, take out the smart contract exchange rate of particular ETH derivative, which is usually way less prone to manipulation, right? Because you don't rely on just liquidity sources, instead on a smart contract security. And then yield protocols, like for example, Bundle or Vita. So going to the main topic of the presentation, what is Oracle extractable value? First of all, I'll give you like a little bit of the history here, or maybe a background, how speed of the information is important. So, does anyone know who that is? Does it ring a bell? Like the pretty famous guy. So, it's Philippides, the Athenian courier that ran first marathon to deliver the information that the Battle of Marathon was won. And he was basically like one of the first guys that were like speeding up to deliver important information. Now, modern example, if anyone knows the story of Flash Boys, it's basically a story of the Wall Street guys that had 1,300 kilometer fiber optics cable that were costed them around 300 mil from Chicago to New Jersey, and it allowed them to reduce latency from 17 to 13 milliseconds. That way, they were able to, let's say, MEV or front run the traders in TradFi, right? Because if a trader wanted to open up a position on pairs or on the stock market in TradFi, they were just faster and could sandwich attack them. Let's say, you don't call that, you don't say that in TradFi, but that's the mechanics more or less, using that optics cable. And now, as you can see, like speed of delivering information is very important since forever. And now we're going to liquidations in DeFi and how they work. So for example, here we imagine we deposited 90K of BTC into Aave and borrowed 80K USDC using that Bitcoin as collateral, right? So effectively that means we shorted Bitcoin because we did deposit 90K USDC, we borrowed 80K of Bitcoin, and now if the price of Bitcoin starts going up, the Oracle updates its price and we get liquidated. And as you can see here, if Bitcoin goes to 100K, in that example, your collateral gets liquidated. But what is more, and what is probably even more important, once Oracle delivers the price and the protocol knows, hey, this position needs to be liquidated, there is still some threshold, so there is still some money left that is used to pay the fee to the liquidator itself, right? Because there's some actual bot that provides and executes the liquidation from the protocol. And now this is a part that is very extractive, and this is a part that a lot of companies and MEV researchers make money on. And just to show you how big of a business liquidations are, here we aggregated liquidations data from Venus protocol. It's a protocol lending market on BNB, which is at around 2.5 billion TVL, total value locked. And as you can see, over the 30 days, this is, by the way, like not the most volatile period. We could actually, if we wanted to, we could aggregate way more volatile period. And as you can see, there is around 1.5 mil of liquidations fee in the protocol that were captured by those liquidator reports, right? Only on majors, right? So we're talking only BTCB, ETH, wrapped BNB here. And now, what if those liquidation fees could be reused and actually the value could be delivered to the Oracle and the protocol itself? So, okay, a little bit more about the liquidation itself, right? So that's the standard liquidation. First, the transaction from Oracle Relier gets pushed on chain. Once it's there, the liquidator tries to get his transaction as the first one right before the Oracle update, right? So he needs to pay the MEV extractors to push his transaction as the first one right after the Oracle updated the price. And what we did is basically, we call that cross-chain abstraction. We used Atlas infrastructure for it, and also Fastlane is the name of a company that helps us implement the whole OEV process. And realized, as an Oracle provider, you could both deliver the data of the price update and also liquidate the remaining positions in one transaction. And this is called single multi-call transaction that can be processed automatically. So now, this transaction works like every other EVM transaction, so it can be implemented on any EVM compatible chain. I think we already implemented OEV on BNB, Berachain, probably hyperliquid. Like basically it can be all the arbitrums and any EVM compilable chain that comes to your mind. It works with, and on top of that, you don't rely on MEV infrastructure at all, right? Because that's the same transaction that delivers data, so you don't need to be fighting to be first later on as a liquidator. And now, okay, so maybe in short, how it works, right? So now we, as an oracle, constantly deliver the data on chain based on set conditions. That is heartbeat and deviation, right? And now the fast lane, so our OEV enable, allows for a bidding process to get the data faster on chain. So basically for liquidators to push the data from our data distribution layer. And now it depends on the situation here. So basically, if there is no one bidding for the price update, we update the price based on the set conditions, right? So 0.5% deviation, or let's say 1 hour heartbeat, whatever that is. But if there is actual bidder in the bidding process, then and just so you know, it lasts milliseconds, right? So the whole action process, it's literal seconds, and it's all automated. There's like no one actually sitting and bidding. There's just bots. But if they see that the oracle price is actually below the liquidation threshold for a particular position, they can decide, the bot can decide itself to bid the action, and if it wins, it's pushing the price on chain regardless of the set heartbeat and deviation, and it's delivering the transaction first to the protocol and to the chain itself, while also liquidating the particular position and getting the liquidation fees. And when he gets the liquidation fees, part of those fees go to us and the protocol, depending on the deal we have. So, what is so important about our OEV solution? The whole process lasts up to 40 milliseconds. It basically means there is no delay, right? Especially for like money markets or lending protocols, this is the update frequency that doesn't change a damn thing for them, and it's just blazing fast. Now, here you can see how the Atlas transaction works. So, main difference is basically, here was the main one. First, relayer update, then transactional liquidation, trying to get as fast, as close as possible to the relayer update. Here, you basically, the transaction is the same. So it's the same transaction that pushes the price on chain and the same transaction that actually liquidates the position. What is more, from an Oracle perspective, and also from protocol perspective, because the liquidator needs to both bid to have the price delivered, but also he pays the gas fee. So this effectively means that OEV, in our example, is actually increasing the update frequency of the Oracle, and like by that also increasing the security. And on top of that, the liquidator is paying gas for this update. So we, or any asset issuer that we deploy the feed for, isn't paying for that gas, which is like additional bonus. And now, okay, so now step-by-step guide of the on the concrete example. So user holds 1 BNB in collateral worth 600 USD. He takes a loan 400 USD. Redstone keeps pushing the price of BNB based on deviation heartbeat. So let's say every 0.1% I think we have on BNB. Then Fastlane, so our OEV enabler, keeps operating auction mechanism, which allows anyone to bid to the right to update the price and background it with the liquidation, right? If the price, for example, it's a very volatile period, right? And let's say we didn't have 0.1, we had 0.5 deviation, and price moved by 0.3%, right? The threshold wasn't triggered, so we wouldn't update the price. But the liquidation threshold for a particular position was triggered, then the liquidator could push the price on chain before the deviation threshold hits and get the liquidation fee for himself. So like the highest bidder would win the action, and then he can just push and liquidate the positions. And now a couple of points about Redstone OEV. So first of all, and this is I think probably like very important thing, there is no need to adjust your protocol to be able to consume or utilize our OEV, which is very important because if you have all those like big lending markets, like for example Morpho, Compound, Venus, they are not gonna change their code base just to get like a little bit of additional revenue stream. I mean, this revenue stream is alright, but still, like they don't want to risk it. Second thing is you have no time added. So basically, auction happens in the off-chain environment, and it doesn't delete the price update. On top of that, it actually is securing protocol from bad debt, because if the bad debt were to occur due to deviation being too wide, it won't if you have OEV enabled for your protocol, because the liquidator will push the price before it would happen with the standard conditions. And like the last thing is basically that you cannot pretty much do anything wrong with it, because the price feed are just keep being updated on the regular basis, and on top of that it's just a separate stream of pushing the prices more often if there is a situation where liquidator can get a fee and make money. Alright, that's pretty much it about the OEV itself. Just last thing, we recently launched our token. Actually, that was last month. You can buy it, you can stake it in the Eigenlayer, Redstone AVS, and join our community. So I invite you very much to do that. Thank you very much, and if anyone has any questions,